Hey guys, Trent and Alex here, and we're going to teach you a little bit about related rates, section 2.6. So by now you should have learned about implicit differentiation. Related rates is a real-world application of implicit differentiation. So what is a related rate? Well, let's say you have a house, which makes a right angle with the ground, and there's a ladder leaning up against the house. The ladder, the house, and the ground all make a right triangle. So let's say the top of the ladder starts sliding down the wall. The length of the ladder cannot change. So as the top of the ladder slides down the wall, the bottom of the ladder will slide away from the base of the wall. In our diagram, that means side Y is getting smaller and side X is getting bigger, and side S remains constant. Sides X and Y are both changing, so they both have rates of change. These rates are said to be related because X and Y are related by an equation, in the case of this triangle, the Pythagorean theorem. But how do you actually find related rates? Well, first of all, you have to know one of the rates to find the other. After that, you use this simple related rates 5-step plan, which we are about to show you. Step 1 is to draw pictures. It's important to visualize what's actually going on in the problem. This also allows you to organize the information you have and identify the information you need to find. Step 2 is to write out the equations you'll be using to relate the rates. Once you've drawn out and visualized everything, and you can see what's going on, you can identify which equations you'll need to use. What exactly I mean by this will become more clear once you see the examples. Step 3 is to differentiate the equations. This is implicit differentiation because you'll be differentiating with respect to time, t, which is almost never in the actual equation. At this point, you'll have to be careful in identifying what in the equation is a variable and what is a constant. Step 4 is to sub in values. When you start the problem, you'll be given all the information you need to solve it. In step 1, you organize this information. Now in step 4, you input all those values into your differentiated equation. Step 5 is simple. Solve. At this point, you should have an equation with only one piece missing. That should be the rate that you're trying to find. Solve for it. Okay, here we go. Let's apply the 5-step plan. As I say the information, Trent will draw it on the board to visualize and organize the information I give him. That's step 1. A house makes a right angle with the ground. A 13-foot ladder rests against that house, 12 feet from the ground. The bottom of that ladder sits on the ground 5 feet away from the bottom of the wall. Suddenly, the top of the ladder starts to slide down the wall at a rate of 1 foot per second. At this point, how fast is the bottom of the ladder sliding away from the wall? Okay, there's our picture with all the information on it. That's the end of step 1. Now for step 2. Write the equation. The picture we drew is a right triangle, and we're trying to relate the rates of two sides of that triangle. So to relate everything, we're going to be using the Pythagorean theorem. But what are x and y? Well, on our picture, any side with an arrow on it is changing. So these sides are variables. Any side without an arrow is constant. In this problem, we'll call the vertical side side y and the horizontal side side x. The 13-foot side is constant. It does not change. Now step 3, differentiate. This is implicit differentiation, so make sure you differentiate with d dt. There he goes, he got it. Now step 4, sub in the variables. Side y is changing at a rate of -1 foot per second, because it's sliding down the wall. Negative. Negative. There we go. Side Y is currently 12 feet long, and side X is currently 5 feet long. We're looking for dx dt, so we just leave that as it is. Alright, now plug that all in to the differentiated equation. And while we're doing this, we may as well just jump right into step 5 and solve this. Okay, time warp time. I just saved you like a minute and a half of time. You're welcome. Let's do another example. This time, we're looking at a cone. Or more precisely, a cup that looks like a cone. The radius of this cone cup is 3 inches, and the height is 6 inches. This is not an empty cup yet. Right now, there's water in it. However, the radius of the water in the cup is decreasing at a rate of 1 inch per minute, and the height of the water in the cup is decreasing at a rate of 2 inches per minute. What we'll be looking for is the rate at which the volume of water in the cup is decreasing at this moment when the radius is 3 and the height is 6. Now we're trying to relate the radius, height, and volume of a cone. So the equation that we'll use to do that is the volume of a cone equation. Luckily for me, Trent knows what it is. Sort of. Now step 3, differentiate it. Now for step 4, plug in the variables. And finally step 5, solve. Okay, there's another example of the 5-step plan, this time using cones. Okay, we're going to show you one last example. This one's going to be kind of funky. Alright, so there's a dude, he's standing over here. He's looking at a rocket going straight up in the air. We're looking at another right triangle. The rocket is at a right angle to the ground. But this time, instead of using a bunch of side lengths, we'll be using another angle, namely the angle of sight, from the guy to the rocket. The rocket is currently 5,000 feet off the ground, and our dude is 3,000 feet from the rocket horizontally. The rocket is currently 15 seconds into its flight. We'll call the 3,000 foot side of the triangle side D, and the 5,000 foot side of the triangle side S. The velocity of the rocket, ds dt, is given by the equation 100t, where t is time. What we're trying to find is d theta dt, where theta is the angle of sight. Alright, on to step 2, the equation. What we have are the two legs of a right triangle, and we're trying to relate them to an angle of the triangle. So we're going to use tangent, because tangent is the opposite leg length over the adjacent leg length. or in this case, side S over side D. However, side S is changing. Side D is not, because the rocket is going straight up in the air. So the height of the rocket changes. The distance to the dude does not. This means that theta and S are the only variables. D is constant. Okay, now step 3, differentiate. Step 4, sub in the values. Now step 5, solve it. Okay guys, so that's a basic overview of related rates. I'll leave you with some closing reminders. Number 1, remember the 5-step plan. If you follow the plan, you really can't do that much wrong. The second most important thing is to figure out what are variables and what aren't. Here's a hint. If something is changing, it's a variable. If it's not changing, it's a constant. The final important thing is to figure out what equation you're using to relate everything. This shouldn't be that hard. Just look at your step 1 and the picture you drew and figure out what equation you're going to use. Okay guys, those are the basics of related rates. I would recommend trying all those example problems that me and Trent left you. We left you some good ones. Have fun!